Okay, so we're going to talk about factoring quadratic expressions, and just as a quick reminder, what that means is this. You know about how to deal with things that look like this. If I ask you to multiply these two things together, you're going to use the acronym we've used before, which is FOIL. So multiply the first pair, you're going to get that. Multiply the outside pair, it's going to get that. Multiply the inside pair, you're going to get negative 5x, and multiply the last pair, you're going to get negative 50. And then you'll combine these two into one because they both have x's, so you'll get x squared plus 5x minus 50. Positive 10 minus 5 is 5. So you get this expression right here. Well, factoring means to go back to this form. Okay? So when I'm going to be factoring something, I'll take the expression that we're looking at there in blue and work it backwards into something that looks like this, with some numbers in there. Okay? So how's this all going to look? Well, there are a couple different techniques we can use depending on how the thing looks. Apparently my board doesn't want to actually erase things. So we know we're going to get it into this form right here. We're doing the simple ones where it says a equals 1. A is always the number in front of the x squared, and basically we have a 1 there. There's no other number out there, so when you see an x squared by itself, you can think of it being a 1. So this is the easy kind, and there's a set of notes in the up on Google Classroom for how to do this. I'm going to go through that right now, and then you can refer to the notes later. So here's the basic idea. We know that this and this have to be an x because we're going to multiply them together to get x squared. When you do the f in FOIL, you're going to do first times first one there, and that'll get you x squared. So if you had anything else, you wouldn't just get plain x squared, you'd get something else. So we'll have an x and an x there. And then we need to find the numbers that go there and there. Well, it's not just any old numbers. They have to multiply together to get 20, right? When you do the L in FOIL, they're going to multiply together to get 20. So they can't be anything random. In fact, it could be 1 and 20, or 2 and 10, or 4 and 5, and that's it. That's the only numbers that multiply together to get 20. Or well, maybe they could be negative 4 and negative 5, because that'd get you positive 20. But the idea is they can't just be anything. So what we did, the first part of the technique, is to write down all of the factor pairs that multiply together to get 20. We wrote them all down there. Okay? The next thing to look at is this. Because this is a plus sign, then either they're both going to be plus or they're both going to be minus. Okay? But either way, when I add them together, I have to get positive 9. Okay? So looking over here at these numbers, which pair adds together to get positive 9? Well, that'd be 4 and 5. So we'll put a 4 here and a 5 there. It actually doesn't matter. I could have put 5 here and 4 there. And then the last thing is decide, should they both be positive or both be negative? Okay? Either way, we get you plus 20. But the nice thing is, see that sign right there, plus? The only way for them to add together to get positive 9 is if they're both positive themselves. So now we factored the thing. Okay? So we're going to use that technique on several other ones. The first thing we'll do is look at the last number here and say it's going to be 30, and we need all the factor pairs. So I'll write those down here. Okay. We know that these numbers are going to be x because they multiply together to get x squared. Okay. These numbers here have to be one of these pairs here, and the nice thing is, this is a plus sign. That tells me to look over here and say, I need a pair of numbers that add together to get 13. So which pair adds together to get 13? Right there, 3 and 10. So I'll put a 3 there, 10 there, and then we have to decide, are they both plus or both minus? Either one would get us plus 30 when we multiply, but the only way for them to add together to get 13, positive 13, is if they're both positive. And now we're done. Okay. Let's look at another one. Okay. This pair, we got 30 again, so 1 and 30, 2 and 15, 3 and 10, 5 and 6. Okay. And now we know still that these are x's, but the numbers here, they're going to multiply together to get 30, but they're not going to add together to get 7, okay? Unless one of them is negative. And the reason I say one of them is negative is they have to multiply together to get a negative number. So either this one's negative or that one's negative. They can't both be negative. And so essentially when we're adding a negative and a positive, it's like we're subtracting. So what this sign right here tells me is if it's a plus, then I look for a pair over here that adds together to get this number. If it's a minus, then I look for a pair over here that subtracts to get that number. Well, which pair subtracts to get that number? 3 and 10. Okay? And the last thing to decide is who gets the negative and who gets the positive. One way you could do it is just say, well, try one pair and then FOIL and see if we get this thing back there. And if we do, we're done. If not, switch them. But what I like to do is say, look, when they add together to get a positive 7, then the only way they could do that is if the bigger number is positive. Okay, that makes this one the negative sign. So basically I look right here and say, if that's positive, make the bigger number positive and the other one negative. If this is negative, then make the bigger one negative. Okay, let's do another one here. This pair, when we get done here, we're going to have x is there and x is there, and the numbers here have to multiply together to get 42. So let's find all the pairs that multiply together to get 42. Okay, and there's a plus sign here, so I'm going to look for a pair that adds together to get 16. Okay, well, it turns out none of them add together to get 16, which tells me this one is not factorable. Okay, so sometimes you get ones that are not factorable. Let's look at another one here. Let's just write one. We'll have x squared minus, let's just try 8x and plus 15. Okay, so we'll write all the pairs that multiply together to get 15. That's 1 and 15, 3 and 5, and that's it. Okay, so I'll look over here and say which pair adds together to get 8. That's 3 and 5. So here we go. We know those are x's. We pick 3 and 5 out of there because those are the ones that add together to get 8. 3 and 5. Should they both be positive or both be negative? Well, they have to add to get negative 8. The only way for that to happen is if they're both negative. Okay, and we're done. Okay, so factoring is not too bad. There's this resource, lots of other resources online that you can use to help you factor. If you're looking for looking for a resource online, Khan Academy or something like that, be sure and look for ones that say a equals 1 or first coefficient is 1 or something like that. Later, we'll do ones where a is not 1. That'll look something like this. Maybe you'll have 3x squared plus 5x minus 7 or something like that. And so this number out front is not going to be 1 anymore. We'll need a better technique for that. I'll teach you that one later.